Great. So we were doing motion in one dimension, right? So let's first go through each and every part. We will break down motion in this is I would give you all the class notes, so don't worry. Just make sure you can see the screen. Someone who's
Someone who's
checking it in
checking it in
mobile phone,
mobile phone,
maybe
maybe
a little
a
bit
little bit
smaller, but
smaller,
then
but then
don't worry. Just I would explain everything. So in motion in one dimension, this screen or this page uh, is a mind map of the entire chapter. So what all you'll be studying in this thing is there in this mind map. So right. So the first thing that we will be studying is we will be discussing about what is motion, what is rest. Rest and motions are, very relative term. We have discussed this. Then you will be studying is the some of the variables like distance, displacement, speed, velocity, acceleration, average velocity, instantaneous speed. Then you'll be discussing about some of the graphs, displacement time graph, and we'll be discussing about velocity time graph and acceleration time graph. After that, we'll be discussing about some of the equations of motion. These equations of motions are quite important, so we would be focusing more time on this. These are my equations of motions. People who have done my last classes will have an idea of whatever we are talking of. People who have just joined, just keep patience. We would be finishing. We'll be understanding after the class, and we'll be understanding each and every concept of it. So we would start with what are the different types of motion. What are the different types of motion here? Motion normally can be divided into four parts. I mean, one dimension motion, where that means motion in a straight line. One dimension motion means motion in a straight line. This is a straight line motion. This is a straight line motion. That means the body is not jumping. The body is not jumping. It is not like this. It is not like this. It is just going in this line, just like your car or your bike or your cycle. Please mute, please mute. Thanks. Right. Okay. This is where we would be discussing mainly of motion in one dimensions. We'll be discussing mainly of the motion of a body in a straight line. The motion of a body in a straight line. Okay, like this. Okay. Then your circular motion. We know circular motion like motion of Earth around the sun. That is circular motion. Okay. Can anyone tell me in this case what is the difference between a circular motion and a rotatory motion? Anyone? Rotatory motion and a circular motion. Yeah, you can unmute and tell me what's a rotatory and what's a circular motion. Okay, more or less correct. See, rotatory motion is about rotating around its own axis. Rotating around its own axis. It does not depend upon your surroundings. It is not rotating. Like for example, you can stand in a place and rotate. You can stand in a place and rotate. Okay. You can stand in a place and you can rotate. Yeah. You can stand in a place and you can rotate like this. Right this. Right. You can rotate like this. But in circular motion, we need another body. For example, this is the globe, and it can rotate like this. But to revolve, for a circular motion to happen, it have to rotate on another body with reference to another body, kind of a thing. For example, if this bottle wants to rotate along this thing, so for circular motion we need another reference. But for rotatory motion we don't need any other references. Okay, that's the major difference between rotatory and circulatory motion. Okay, right. Let's Okay, right, great. Okay, now then you have got uniform motions and non-uniform motions. Uniform motion means that if someone is travel. Please mute, please mute. Yeah, if anybody is traveling or equal distance in equal time, equal distance in equal time, that means the speed is constant. That means, let's look at our earth is rotating along its axis, and it is rotate doing this in every 24 hours. It is doing this in every 24 hours. So once it is doing it in every 24 hours, it is not changing. It's not, sometimes it is 25 hours, sometimes it is 23 hours, sometimes it is 20 hours. No, it does not happen that way. So its velocity is constant. So uniform motion means the velocity is constant. The velocity is constant. Okay, right. And then there is a non-uniform motion. Non-uniform motion is all motions that we are doing, like we travel in a non-uniform motion. Sometimes we travel faster, sometimes we travel slower, sometimes we are going through a crowded market, then our speed goes down. Sometimes, kindly mute everyone, please mute the microphones. My humble request, please mute the microphones better. Great. And I hopefully everyone is able to see the screen. Great. Okay. If someone is not able to see the screen, then say no. Everyone should not have to answer yes, 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 yes. Okay. Non-uniform motion is something that we are normally motion of a car in a crowded road. We increase the velocity. That means velocity changes. Velocity changes. Okay. Right. Now coming to this motion, there is a very important concept of motion and rest. There is a very important concept of rest and motion. I will come back to this slide. There is a very important concept of rest and motion. This is relative. This is relative. No, relative does not means like friends and families. It just means that there should be, if someone is at rest, we have to tell with whose reference you are at rest. For example, we are all sitting on our chair, bed, desk, wherever, and we say, okay, we are all sitting down, so we are at rest. There is no motion. But if someone is looking at us from moon or from other planetary object, they are seeing that no, this everyone is moving along with the earth. So with the reference to our surrounding, we are at rest. With reference to our surrounding, we are at rest. But with reference to someone outside this, outside the earth, we are in motion. We are in uniform motion. So whenever we talk of we are at rest or we are at motion, for example, you guys are traveling in a train, and uh, and people seeing outside, from outside sees that you are at motion. Great. But people who's sitting adjacent to it, so the পাশে যে বসে আছে, the person who's sitting along with you inside the train, you are at rest. So rest and motion is totally relative to what? Relative to your surroundings, relative to your surrounding, immediate surrounding. Okay. For example, if you guys are moving in an escalator, okay, and people who are standing in the ground, oh, this person is moving, great. But if you and your friend is moving in the escalator the same speed, you both will be at rest. There is no change of position of yours with respect to your friend. So rest and motion is relative. There is no there is no there is no absolute, there is no absolute rest or motion. There is no absolute rest or motion. Okay, this is important, right? Okay, this is very important. Next we are coming to a concept, distance and displacement. Distance and displacement, though they almost they almost represent the same physical quantity, that is change of position, but there is a subtle difference between this distance and displacement. For example, if you're traveling, if you're moving from a point A to point B, where this is your house and this is maybe your school or your friend's house, there we know we have multiple path. We can go via this road, take this route, or you can travel via this route, or you can travel via this route. All we know to reach point A to point B, there are multiple paths we can take. Okay, for example, like you are going from traveling from Kolkata to Delhi. uh, you can go by flight. There will be different path. Maybe this is my flight, yellow one is my flight route. Maybe flight this is my flight route. Okay. Or you can go via train. Maybe this one is my train route, right? Or you can go via car. Maybe this one is my car route. We are not sure. We are not sure which route we will take. All depends upon our requirements. So based on which route we take, the distance will change. So distance depends upon what? Distance depends upon the path we take. Depends upon the path we take. Right. Right. But displacement in physics means the shortest distance from A to B, the shortest distance from A to B, shortest distance. Okay. Displacement means shortest distance. That means the straight line. That's my displacement. Okay. Whenever we talk of how far is Delhi to Kolkata, we take the displacement, the shortest distance. We don't say, okay, Delhi to Kolkata, if you go by car, this will be this far. If you go by train, this will be this far. If you go by flight, this will be this far. The distance from Delhi to Kolkata in map will not change. Distance between Delhi to Kolkata in map will never change. Okay, so that is the displacement. But distance can change based on the path we take. Right? Okay, so when we start talking of distance and displacement, for example, if you are going displacement is somewhat funny sometimes. If you have gone from A to B, and if you have come back from B to A again, your displacement will be zero, because displacement check the initial position and the final position. Here the initial position was A, and again you have come back to A, so your displacement is zero. But distance will not become zero. But the distance will not become zero. But the distance will not is not zero at this point. For example, from your house to your school, if it is 3 kilometers, you have gone to school and come back from school. At the day's end, what is the displacement? Zero. I have, as if I have not traveled anything. But your distance is 6 kilometers. You have gone 3 kilometers and come back 3 kilometers, kind of. Okay, so displacement is a vector quantity, and distance is a scalar quantity. Okay, a vector quantity has magnitude as well as a direction. This has got a value, plus this has got some direction. It all depends upon which direction you are traveling. A scalar quantity just has value. Just has value. It does not have value, means a number. If I say 5 kilometer is a number. But then if I have to say 5 kilometer northeast, from north towards east, when I'm traveling, so that time it is it is a distance. Sorry, it is displacement. So the distinction between, or the difference between distance and displacement is important. That could be a 2 marks question. Okay. uh, Distance depends upon the length of the path, and displacement is the shortest distance. Distance is a scalar, displacement is a vector. Distance depends upon the path it is flowing, and displacement is independent of the path. And so these 4 points are important. It might come for your exam. But the basic difference between distance and displacement is displacement is change of final position and initial position, and displacement is change of final position, initial position. Distance is the path we take. Distance is something that you have known. Why are you talking of distance and displacement? Because uh, in motion, in physics, it depends so much on the path. The displacement, when you are talking, we'll be talking of physics, and here, especially in this chapter, especially in motion chapter, and the next chapter, that laws of motion, we will be discussing on the displacement thing. We'll be more concerned about the displacement of a body, not the distance of a body. Okay. Next will come about, we'll talk about speed. We all know speed is equal to distance by time. We have been doing this for ages, I think now. Okay. And its SI unit is meter per second. Okay, it's a scalar quantity, right? But similar to speed, we have something called some sorry some we have something called a velocity. A velocity is, the formula remains the same. So instead of distance, we have got displacement, and it is also a vector quantity. So velocity value will be the same, but it is displacement by time, and it's a vector quantity. It's a vector quantity, right? Okay. These there will be some difference, like we have got difference between distance and displacement. We will have difference between speed and velocity also, which is very important conceptually. Okay. Okay, let's, when we are discussing about speed, let's talk about a few things. What are the different types of speed we have been discussing about? Uniform speed, that is, the speed is not changing. That is like we are moving in an escalator. Alright. If I'm moving in an escalator, it does not happen sometimes escalator is going faster, it is going slower. No. It is going at the same speed, right? Or non-uniform speed is something like that, something like we normally travel based on the traffic, we change our speed. Or if I'm if I have switch on a fan and put it at regulated 2, the fan will move at a uniform speed. Then if you had put it at regulated number 3, it will increase the speed. And then if you feel cold, you can switch off the fan, it will come to 0. So these are the difference between a uniform speed and a variable speed. But but the most important in this chapter is this two type of speed. One is an instantaneous speed, one is an instantaneous speed, and another is average speed, why these two are important? These two are important, very very important, for a particular reason. For example, you are traveling by a car, and we have this speedometer of this car. We have this speedometer of this car where you have this 0, 20, 40, 50, 60, till we have got maybe 150, right? And this, right? So we see at any moment we can see that speed. Okay, now we are moving in a moving thing, and we see that, okay, what is our speed? We see this is 60. That means at that particular time, or at that particular instant, at that particular time, or at that particular instant, my speed is 60 kilometer per hour. My speed is 60 kilometer per hour. Okay, it is not my, it's not possible that my entire journey I will move at 60 kilometer per hour, because we'll have bumps, we'll have traffic. So if I might reduce, I might increase. Maybe after some time we see there is a lot of broken roads are there, so maybe our speed become 20 kilometer per hour. So at that instant, or at that moment of time, we are 20 kilometer per hour, right? So this is instantaneous speed. So the speed our car speedometer, car speedometer measures speedometer measures is the instantaneous speed. Is not the average speed, is the instantaneous speed. Okay, that particular instant. Okay, the example is given out here, right? And then what is the average speed? Now maybe you're traveling from Kolkata, maybe from Baharampur to Kolkata. It's 200 kilometers. Sometimes you will travel at 80 kilometer an hour, sometimes 100 kilometer an hour. These are all instantaneous speed. Sometimes you will stop, sometimes you will travel at 40 kilometer an hour. So how do you know what's the average speed? What's the average speed? So what you will be doing is, instead of adding all the speed and dividing it by 3, no, will not be doing this, will not be doing this. We would do the total distance. Maybe the total distance from Bahrampur to Kolkata is 200 kilometer, and maybe I have taken 5 hours time. I have taken 5 hours time. So this is what we will not be bothered about the instantaneous speed part. What we will be bothered about is my average speed, because you can zoom and then you can slow. So it does not matter how fast you are traveling on a particular span of time. It does not really matter. What matters, the total distance you have covered in the total time. So then my average speed would be or this average speed, sometimes I've gone higher, sometimes I've lower. My average speed is 40 kilometer per hour. So normally when you start from your house, maybe from Bahrampur, you start at 6 o'clock in the morning, and you are reaching Kolkata. It's 200 kilometers time. Sometimes you can go fast from here to Krishnanagar. The road is fantastic. From Krishnanagar towards Ranaghat and other places, the road is broken. It's a single lane road, so the speed will go down maybe at 20. Here we think we can increase the speed at 60 or 80. So we know it will take around 5 hours. How do you know it will take around 5 hours? Because we know on an average maybe you will travel at 40 kilometers an hour. So we take the average speed, and the average speed is something that helps us calculate the time that will take to cover a distance. Average speed is something that will help us calculate the time taken for a particular distance. Okay, so this was your average speed. Okay, which these two are very important. Average speed, same thing like speed. We have got uniform velocity, we have got this uniform velocity, non-uniform velocity, instantaneous velocity, and then you will have your average velocity. Velocity will be used when displacement is taken care of, and speed will be used when distance we are talking about. Okay, right, right. So let's see what else we have next. Okay, again, average velocity. Then the difference between speed versus velocity, which is again important in terms of maybe 2 marks question. Just make sure you learn this, you practice this kind of a thing. Right. Next comes a very important concept that we all have heard of, that you have all heard of, but but normally we haven't calculated yet. We all know what's an accelerator is, right? We all know what's an accelerator is. Accelerator is something that they're in your car, right? Okay, we have got clutch, brake, and accelerator. Okay, well, let's forget clutch for sometimes. Like we have this paddle. One is accelerator, and let's say another is a brake. Okay, right. Accelerator, as the name suggests, increases our acceleration. Accelerator increases our acceleration. What is acceleration? Acceleration is nothing but change of velocity per unit time. This is nothing but change in velocity per time. Okay, acceleration is nothing but change in velocity per unit time. That means if I press an accelerator, my velocity will increase. Whenever I press an accelerator, my velocity will increase. That means I am moving at maybe 40 kilometers an hour, and then I see a road stretch which is totally empty, and I put down my accelerator, and my velocity increases from maybe 40 kilometer an hour to 80 kilometer an hour. right? And this happens maybe in 10 seconds. This happens maybe in 10 seconds. So my acceleration, I will calculate my acceleration as calculate my acceleration as, okay, first, uh we have to make sure that this is per hour and this is second. So I can change it whatever it is. So 80 minus 40, that is my final velocity. What has I got? Subtracting my initial velocity. This is my final velocity that I've achieved. My initial velocity was this, okay, and I have achieved it in 10 seconds, or maybe in 60 seconds, maybe for namesake it is 60 seconds. Okay, so this is all in kilometer an hour, and this is in 60 seconds, so I have to convert this into hours. 60 divided by 60, that is in minutes, divided by 60. So this two got cross out, and we can say 40, and the 60 goes off. 40 into 60, okay, which is 2400, and my acceleration is kilometer per hour square. That's my unit. Or the SI unit normally we use is meter per second square. We are normally, in most of the problem we use meter per second for velocity in terms of unit, and for acceleration we will be using meter per second square. Okay, because see this formula. On top we have got meter per second, below we have got second. So I'll just write it more clearly, maybe. Yeah, on top, v minus u, this is we have got in, we have in meter per second, and below also we have got second. So this second comes down unit wise, so it will be meter per second square. Okay, that's the unit of acceleration. That is, or by definition it is rate of change of velocity. It is rate of change of velocity, right? So also, just like your velocity, we will be having uniform acceleration, we'll be having non-uniform acceleration, we'll be having acceleration due to gravity. Okay, uniform acceleration means the velocity is changing, but this acceleration is continuous. Slowly it is changing at the same pace. We would understand when we would be doing some of the graphs. Okay. Second is non-uniform. That means sometimes you are accelerating, sometimes you are braking, sometimes we are stopping, sometimes we are going faster, like this. And third is acceleration due to gravity. This acceleration due to gravity happens. We can see when we throw a ball. When we throw a ball on an upward direction. What happens when you throw a ball in upward direction? This ball travels for some time, and then it stops, and then it starts falling again and come to its initial position. So this happens because, why is this ball falling down? This is because of your acceleration due to gravity, which we fondly know name as g, and we know this is 9.8 meter per second square in earth. In earth, okay, in this world. If you go to moon, it will become 1/6 then. Okay, right, we have been used this g when you have found out the weight of a body from Mars, because weight is equal to mass into acceleration due to gravity. So we'll see this. So that's bring us to the concept of acceleration. Okay, right, great. Now let's talk of retardation. Like acceleration, retardation is negative acceleration. That means I'm traveling at 80 kilometer an hour, and while traveling I see a person. This is my car. I'm traveling by a car. Okay, and then just in front I see a goat. I see a goat in front of this, or some people traveling. Okay, so what will I do? Okay, what will I do? I will stop. I would stop. Or I see, I'm so sorry. Okay. I see someone traveling. I see some people crossing, some person crossing like this road. What will I do? I would, I would apply brakes. I would apply brakes. Okay. Once I apply brakes, what happens? My car will slow down. Slow down means my velocity will become less. My velocity will reduce. Will reduce. Okay. My velocity will reduce. Okay. When my velocity is reducing, so initially my velocity was 80 kilometer per hour, then suddenly it become 20 kilometer per hour, because by the time I will reach that place, the person will travel. So I always know acceleration is nothing but final velocity, which is 20 minus 80, whatever time, maybe in I did it in 10 seconds. Okay. So you see the numerator will be negative. This negative means, this negative, there is nothing, the negative has a significance. The only significance of negative means acceleration is negative, means it's a retardation. Negative acceleration means my speed has reduced. That is the significance. It's not that negative numbers kind of a thing. It means retardation. That means my speed has, I have reduced my speed. I have reduced my velocity. Negative acceleration means retardation. Okay. This is why it's important. Right. So these was the basics about when you have studied about different types of motions, kind of a thing. The basic thing. Right. And now what we'll be focusing mainly on, some of the graphs, and which is very important. Okay. I would give a 2 minute pause. I would give a 2 minute pause, and just a 2 minute, and in that pause you guys will think about, have you understood this portion of it. Don't ask question in this 2 minutes. Just after 2 minutes, this 9:23, at 9:25, I will ask you if you have some problems. If you have some problems understanding till this. Okay. Please tell me, any doubt till this? Anyone? Okay, beta. Tell me what's. Okay, see, normally question wise, most of the times you have seen go through the question, they've spoken about displacement. The formulas that we use, we always talk of velocity and displacement. We hardly talk of speed and distance. So S is a symbol for displacement. S in physics is a symbol for displacement. We would never talk from your class 9 onwards. We will never talk about the distance covered. We'll always talk about the displacement in physics. Okay. So we would, as we go higher, maybe in class 11 or 12, we take physics. We would always talk of vector quantities. We will hardly talk of scalar quantities, because we are talking of a motion that is happening actually. It is not some kind of a let this body is traveling at this speed. No, it is actual motion we are talking of. In actual motion, we'll have direction. Car can go this way or this way, or car can go, I'm going like this, and again I can go back like this. So we would be having actual motion. In actual motion, we would always talk of displacement. So S is a symbol for displacement. S is a symbol for displacement. Okay. There will be some questions they will ask, what is the distance travel? That means in this kind of a problem, that means displacement and distance are same thing. That means the body is not changing any direction. That's why they are asking for what's the distance travel. So there won't be any confusion, because at the day's end we will use the formula S, but while writing the answer, whatever the question, if the question is asked for the total distance travel, you will write the total distance travel is this. If they have asked total displacement, you will say the total displacement is this. You will not write total S is this, right? So that, I think, answers your question in terms of this. Is it? Does it? Does it answer your question? Okay. Anyone else? Any doubt till here? No? No? Everyone is connected, right? Everyone is connected. Great. Okay. Right. No doubt. So I think I can move on. Let me move on then. Okay. Now it's very important you understand this thing very carefully. I think this will be the crux of your entire chapter. This graphs. We have extensively discussed these graphs prior, but now this is a revision class, so I would again discuss it again. Right. This is a displacement time graph. Means on my x-axis I have got time, and on one my y-axis I have got displacement. That means I'm plotting it. I'm plotting like we do x-y plotting in simultaneous linear equations. In your maths, we are doing this plotting. So as time goes, I'm seeing how displacement is changing. Like, okay, and look at this first graph. In the first graph, as time is increasing from 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, my displacement is same. This is same. This is not changing. This is not going up like this. Okay. But this time is changing. See, 1 second, 2 second, 3 second. For all time period, my displacement is on a straight line. My displacement is a straight line. That means my displacement is not changed. This means I'm talking about a stationary body, or this body is at rest. The body is at rest. Body is at rest. That means I am not talking about a body which is moving. Body does not have any motion. The body is at rest. When the body is at rest, what is the speed or what is its velocity when the body is at rest? Anyone? When the body is at rest, what is the speed or velocity of this body? Zero. That is exactly the velocity is zero. There is no motion happening. There is no motion happening. People can ask at this sir, why is this line at between 20 and 30? Why not like this, or why not like this, right? It could have been anyway. That means, please mute. Yeah, that means the the instant that I'm seeing that, if this is my zero, this is my starting point, maybe the person has started from his house and then went there and stand. It is not moving after that. So anyway, it could be the displacement line could be like this, or like this, or even whatever it is given. This always means the body must be from the starting point. It is at 20-meter far, it is at 40-meter far, or even 28-meter far, but then it is not moving at all. The instant that I am recording is some person is standing just like that. Some person is standing just like that. Maybe away from his starting point, but then that person is not moving at all. When the person is not moving at all, the body is at rest or velocity is zero. So you will get this kind of a graph, and they will ask question, what is the velocity of this body, what is the distance traveled, and all these things. Okay. Now come to the next case. The next case is when the body is at uniform velocity. That means 1 second, at 0 second my velocity was 0. Okay, let us draw this curve out here. Let us plot this. This is my time, and maybe this is my displacement. Okay, displacement I am denoting by s. Okay, so here when it was 0 second, my displacement was 0. I just started. When it is 1 second, my displacement c is 10. When it is 2 second, my displacement is 20. When it is 3 second, my displacement is 30. When it is 4 second, my displacement is 40. When it is 5 second, my displacement is 50. Okay, right. So this is kind of a figure. Okay, this is my displacement. I would give the unit as meter, and this is my time. I will give the unit as seconds. Right. So these means at equal interval of time, that is from first 0 to 1, I have moved 10 meter. From next 1 second to 2 second, I again move 10 meter. This is also 20 minus 10, which is 10 meter. For next 1 second, I have again moved 10 meter. For then 1 second, I have again moved 10 meter. So for every second, I am moving 10 meter. For every second, I am moving 10 meter. That means I am having a uniform velocity. I am having a velocity. Uniform means constant velocity. Uniform velocity means constant velocity. Sometimes you might say, sir, what is uniform velocity? Uniform means constant. Like we wear our school uniform, we call it an uniform because it does not change. It's not that Riddhi will on a Monday she will wear one kind of a dress to school. On Tuesday she will wear another kind of a dress to school. No, the dresses are constant. The school dress is constant. That's why it's called a uniform. Here also uniform velocity means constant velocity, right? But how from a displacement? This is a displacement time graph, and we say dt graph, dt graph or displacement time graph. Okay, how from a displacement time graph we can calculate velocity? See, what we will do while calculating velocity, we would find the slope. We would find the slope. What is the slope? Slope মানে হচ্ছে কতটা ঢালু। দেখ এইটুকু পয়েন্টে দেখ। So now if we have to find the slope, let's say from 0 to 1, from 0 second to 1 second, what is the velocity? So we would do what is my change in displacement from 0 to 1 second. What is my change in displacement? 10 minus 0 meter. This is from 0 to 1 second I'm checking. Okay, from this point to this point. And what is my change in time? Oh, the change in time is 1 minus 0 second. Okay, so this is called a slope, which gives a velocity, this which gives a velocity for this time period. So 10 by 1, that is my 10 meter per second. Meter by second, 10 meter per second, that's a unit. So slope means change of y. Slope means change of y divided by change of x. Okay, let's say from 4 second to 5 second, what is my slope? That means how much is this slope? That means we would do this, we would try to find this. That is, what is my change here? My change in my change in displacement here from this point to this point is 50 minus 40, which is again 10 meter, right? And what is my change in time from this point to this point? What is my change in time? See, 5 minus 4, that is 5 minus 4, that is 1 second. So this is again 10 meter per second. So my velocity is constant. So whenever in a displacement time graph we would get this kind of a straight line. See, this is a straight line also. Okay, this kind of a straight line, we know we are talking of a constant velocity, and the velocity to be defined by the slope of this graph. Velocity would be defined by the slope of this graph. This is what will give us what is the velocity of this body. That means the speed, the body is moving, but not at the change speed, at a constant speed. So whenever the graph will look like this. See, I have put down this data. We have put down this data. We take this kind of a data and we start plotting the graph. We will get this kind of a figure. This kind of a figure. This is my second case scenario. This is my second case scenario. Okay. Right. Now let's go displacement time graph. We had this kind of a figure, right? This is this kind of a figure. That time the body was at rest because I was plotting displacement here. So same kind of a curve, same kind of a case. Right. Okay. Third, instead of that, a straight line, again for a displacement time graph, if my curve is like this, like means this is my time axis, this is my displacement axis, okay, and I am plotting, I'm getting a curve. I'm getting a curve, which means the body is moving at a variable velocity. That means sometimes I'm putting an acceleration. That's why the slope at every point is not the same. The slope at every point is not the same. But how do you know that? Let's plot it. Let's plot. This is my time. Okay, just a second. Let me give it a few more space and let me do it this side. So we can we can we can do it here. Right. Let's plot this time in seconds versus displacement in meter. Okay, see, when the time was 0, this point P point, the displacement was 0, which is great, the body just started. Now when I have reached 3 seconds, my displacement is 10 meter, which is great. When I've reached 5 seconds, we can do it in any point, we can even do it in this point also, okay. But when I've reached 5 seconds, here I'll just take the point, my displacement is 30, okay, great. When I've reached 7 seconds, my displacement is 50. So now let's calculate the change for this first 3 seconds. My change of displacement is 10. So here for 3 seconds the change of displacement is 10. For next 2 seconds, mute. For next 2 seconds, my change of displacement is 20 meter. For next last 2 seconds of my graph, my change is 20 meter. Okay. Actually, look at this. The 7-second curve, it will go this, but then if I take this, so maybe this is not 7. This is not 7. This is 6.5. Okay, if I try to plot it here, because 50 has reached when this point is here, or maybe 5, for 5 we got 30, great, for 5 we got 30, right. And for 3, for 3 second, maybe we have not got 10, we have got 15, so this may be 15. So for the 0 to 3 seconds, this is 15 meter change, okay. For next 2 seconds, this is 15 meter change, this is 15 meter change. For the last 1.5 seconds, this is 20 meter change. Now if I try to see change, this is from 0 to 3, that is 3-second change, I have got 15 meter. So here my velocity is 5 meter per second. For this motion from 5 to 3 to 5 seconds, again 15 meter. So in 2 seconds it is 15 meter. So now it is 7.5. That means my velocity is increasing, okay. For last 1.5 second, it is 20 meter. For this area, it is 20 meter change. So that is 20 by 1.5, which is how much goes up, and we'll get 200 by 15. You can do this calculation, 200 by 15, and you can find out this is 13.3 meter per second. So sorry. So we can see this curve that as time goes, the my velocity is changing and it is increasing. So see, this graph is become steeper. This graph is becoming steeper. Steeper means the velocity is increasing. Steeper means the velocity is increasing. Like that, this is normally our motion, right? We start cycling, we start our bike, and slowly we're increasing the speed. As we go more time, the speed increases. Okay. So it started at 0 meter per second, and within 6.5 seconds, it has given me 13.33 meter. And see how was a how has it increased? First 3 seconds it was increased, then it is increasing like this, then it is increasing like this. So this is an accelerated motion. That means there is some acceleration happening. There is some acceleration happening, and that's why the velocity is changing. So that's why it's a variable velocity curve. Okay. That's why it's a variable velocity. Okay, this is what has gone to displacement time. Now we'll come to another very important topic, which is velocity time graph. Now instead of plotting displacement in y-axis, we will be plotting the velocity part of it. We will be plotting the velocity part of it. Let's see how does it look like. Okay, let me maybe this. Sorry, like I'm so sorry. Okay, I'm so sorry. Let me go back there. Let me go back. Let me go back there. We did our but in different. See how does it? I would have look like time graph situation. I would give you. Yeah, this is a better thing. Okay, look at these curves. These are all velocity time graphs. That means on x-axis I have on my x-axis I will plot time. This is my x-axis. This is my x-axis, and on y-axis I will plot velocity. So look at the first figure out here. As time goes, the velocity is constant. A straight line curve means the velocity is constant. As time goes, my velocity is constant like this. So what kind of a motion is this? This is a uniform uniform motion. That means the body is moving but at a uniform speed. The body is moving and the uniform speed. This is my speed. This could be anything. Maybe this is let's say this is 10 meter per second. This is 10 meter per second. This point. So as time goes, my body is moving, not at rest. My body is moving, right? If instead of this graph, yeah, yeah. Instead of this, if my curve would have looked like this red line is my curve. Can you tell what kind of a motion would have been like if my curve would have looked like this, the red line? Anyone? Anyone? You can unmute and give me an answer. Anyone? Hello. This red line. This red line is my curve. Obro, Romet, Ishika, Shumona. What kind of a motion would that be? In a velocity time. Yes, better? Uniform motion. Okay. Who else can throw some light in this? Who else can throw some light in this? What kind of a motion? Okay, tell me what's the velocity of the body? If my line would have looked like this, the red line, what kind of zero zero will at, so why the body is at rest? Because my velocity is zero. So it's a uniform motion, but there is no motion at all. Okay, so Okay, it's a velocity time, but the velocity is zero, but my speed is zero, zero, zero. Okay, chalo, good. Okay, but normally normally for a curve like this, for a curve like this is uniform motion. Now, in our displacement time graph, in our displacement different depends on what I'm plotting. The my answer would be different. In a velocity time graph, a straight line or parallel line parallel to x-axis means the body is having a constant velocity or uniform motion. But same thing if it would have come in a displacement time graph, that means the body was having a constant displacement. That means the body was at rest, it was not moving. Okay. Now coming to the next curve, what kind of a motion? Hmm? The velocity is constant. Is the velocity constant here? At at this point the velocity is this. At this point the velocity is changed. So it's a non-uniform motion. It's a non sorry. It's a non-uniform motion. It's a non-uniform motion. Non-uniform motion means Monday one dress, Tuesday another dress in school. Okay. The velocity is changing. The velocity is changing. Okay. The velocity is changing. The velocity is changing. Right. Look at the third curve like this. Just almost the opposite of the maybe second curve. This also velocity is changing. First the velocity was this high, then it is come here. So what kind of a motion is this? Again non-uniform, non-uniform, non-uniform. But if in this case, B case, if the velocity was increasing as the time is going, here the velocity is decreasing. That means this is having an acceleration and this is having a retardation. That means I have applied a brake. That's why the velocity as time is going, my velocity is reducing. My velocity is reducing. This is also non-uniform motion, but my here I will say my acceleration is positive. If I say in this case acceleration positive, here I will say acceleration is negative. Acceleration negative means is retardation, or there is a I have applied my brakes. I have applied my brakes. Okay, right. Great. Now look at graph number D. Very similar to graph B, but instead of starting from 0, it has start from some point. It has start from some other point in the y-axis. You know what's the only difference between B and D? Graph B and D, what's the only difference? Anyone? Can you tell me the difference between B and D? Riddhi, what's the difference between B and D? Graph B and graph D? In graph B, my initial velocity was 0. Yes, beta? Tell me, tell me, tell me. No idea. Okay. Okay, great. Sometimes having no idea is good than to have some wrong ideas. So, better. Good. We'll listen to what our teachers say. Yeah, in graph B, my initial, the starting point, my velocity or my speed was 0. I started from rest. Here, my speed is not 0. I have some, maybe this is my 5 meter per second. Okay. Then slowly as time went, I have gone to maybe this is 20 meter per second. So I my velocity is changing, but initial velocity was not 0. But in B, graph B, my initial velocity was 0. This is initial velocity, which will denote it by U. My initial velocity is not 0, but here my initial velocity is 0. So I have not started from rest. It is something like this, like I was moving, at 5 meter per second. Great. Suddenly, this is something like a roller coaster, right? So I was moving at some time. Suddenly there was a drop, and then my speed increased, and my speed has increased. So my initial velocity was not 0. I was moving at a speed. But then suddenly I put an acceleration in this point. I have put an acceleration from here to here. I have put an acceleration on the accelerator. Okay, my acceleration is positive. So I was moving at a point, and maybe I was just going, like, think you guys are feeling like, "Arey, yaar, I'm getting bored sitting at house. Let's go out." Then you just strolled outside and said, "Let's have some tea." Then you went to a tea shop kind of a thing, strolling around, and then suddenly you saw some police coming, chasing you with a stick. डंडा लेके पुलिस आ रहा है, तो क्या करोगे तुम? अपने वेलोसिटी को इंक्रीज करोगे ना, ऐसे भागोगे. किधर भागोगे? जिधर रास्ता मिले उधर भागेंगे, kind of a thing. So you're accelerating your motion. You're strolling easily, relaxing, घूर चिलाम देख चिलाम. अच्छा, इस दुकान भी बंद है. अच्छा अच्छा, वो दुकान भी बंद है. You are roaming around, and suddenly I saw a police van, and I start running. Almost I started running. You know what is going to happen. So that kind of a motion was that. You are not starting at rest. You are coming with the initial velocity, and then you are starting. Okay. Right. Now this was like all straight lines. Let's come to this curve. This curve is very similar to your last displacement time curve. The only difference out here is I have plotted velocity and time. Please mute. I can hear someone talking behind. Great. Thanks. Okay. So here it is not a straight line. What kind of a curve it is? It is a slightly curvature curve. This means as my time is increasing, my velocity is changing, okay, but my acceleration is also changing, because at this point I have a different velocity. At this point also I have a different velocity. But this is not unlike B or D or C. This is not a straight line. This means I am having a non uniform acceleration. My velocity is changing, but my velocity is not changing at the same pace. Sometimes my velocity is changing less, sometimes my velocity is changing more. That means it is an accelerated motion, but even the acceleration is non-uniform. এরকম না কি আস্তে 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 একইভাবে I'm increasing the speed. I'm increasing sometimes so high, and then higher, then higher, kind of a thing. This is an accelerated motion, kind of a thing. Okay. Okay, let us that we are seeing out here, right? Here in this graph that we were doing was, okay, yeah, this graph was talking of a non-uniform acceleration. That means at every point not only the velocity is changing, the acceleration is also changing. But this graph is quite uncommon in your kind of a cases. This happens when I'm pressing my accelerator. Imagine I'm pressing my accelerator and I'm continuously changing my accelerator. Like I'm pressing harder, then harder, then harder, then harder. Like I'm increasing the speed as well as, but not in a uniform manner. Not in like this. I'm not increasing the speed like this or like this. I'm increasing the speed, kind of a thing. Like if I try to enact it, how does the sound of this will look like? You must have seen there are some some guys who rides up motorcycles very fast, and when it passes, you like, "Ooh," that kind of a sound you will hear. If I'm trying to imagine how does it look like with a non-uniform acceleration, that means I'm accelerating, and that acceleration is also increasing at every time. Okay, you can see this if you're watching a motor race, or if you're watching a bike race. But I think during lockdown you're not able to see or hear. But even at 12 o'clock at night, when I'm at my home, I can hear some kind of thing. Whoa, kind of thing. Like it is like some bullet is going or something like that. Some bikers gang are traveling, like that kind of emotion. This kind of emotion, E-type motion. This kind of emotion we are talking of out here. Right. And finally, this is F graph is so important because this kind of a graph will come in your exam. Look into this. Let's discuss this. Very important graph. I think one of the most important graph of the entire class is this. Initially, at 0, was having no motion. From here to here, I was having no motion. My body was at rest. And then I started, I've put the acceleration. I put the acceleration, and my velocity is increasing. From A to B, my velocity is increasing. This portion, my velocity is increasing uniformly. My velocity is increasing uniformly. Then from B to C again, my velocity is constant. I have not come to rest. See, my velocity is constant. My velocity is constant. And then again from C to D, I have reduced. I am reducing my velocity. I am reducing my velocity, and at D point I have come to rest again. My velocity is 0 out here. So this is my velocity equal to 0. This is where I am. Velocity is negative. Velocity is negative. That means I am reducing my velocity. Reducing my velocity, which means I have applied a brake. I've applied a brake. Applied a brake. This is my uniform retardation. This is my uniform retardation. Retardation means negative acceleration. This is my uniform retardation. Okay, retardation. Okay. From B to C, at this point, my velocity is constant. My velocity is constant. No acceleration, no retardation. Whatever velocity I have reached out here, maybe this is my 20 meter per second point. Okay, maybe this is my 10 meter per second point. Yeah, when my velocity is constant, my motion is uniform. This is my uniform. Zero acceleration here is equal to 0. My velocity is constant, my motion is uniform. I am having a motion which is a uniform motion. This is my uniform motion. Okay, and my velocity is constant. Okay, from A to B, what is happening? I am accelerating. I am having some positive acceleration. My velocity is changing. My velocity is increasing. My velocity is increasing. Okay, my velocity is increasing because I was having a zero velocity here. I was having a zero velocity here. Now I have start on the acceleration at this point. At this point, I have started my acceleration, but constant acceleration, positive but constant acceleration. I have just একবার আমি এখানটাতে acceleration দাবিয়েছি, and my suddenly my velocity has increased this much, right? I have not continuously pressing my acceleration. I have just once, and it gave me an acceleration of it gave me a velocity of 20 20 meters. So maybe if this is my 5 seconds point, this is my 2 second point, or this is my 4 second point, 2 second point, 0 second point, and like 6 second point, and 8 second point, and 10 second point, and maybe 12 second point. Right, I can put any values just for the sake. From 0 to 2 second I was at rest. At 2 second I pressed an acceleration. So in this point, in this 2 second, I have reached a velocity of 20 meter per second, right? So I can calculate my acceleration. 20 by 2, which is 10 meter per second square, is my acceleration I have given at this point, A point, and I have reached this velocity. Then from B to C, I have removed my leg or feet from the accelerator, and I am moving at a constant velocity. So this kind of a problem will come in your exam. This kind of a problem will come in your exam. So this is a very important graph. Okay. Now, one more thing I need to discuss before we move on is how to calculate velocity, how to calculate acceleration and displacement from graph. Okay, let us put it this way. Okay, see. Okay, this was the same thing that we have done. I mean, in last class we have done this. Okay, uh, last to last class we have shown. So, which is great. Okay, let us come to this point where we would be discussing about how do you calculate from a velocity time graph, how to calculate the displacement and distances. Like for example, this is my time axis and this is my velocity axis, right? Now I may be having uh, a uniform velocity like this. I'm increasing, not uniform velocity, it's an ununiform velocity. I'm increasing, right? Maybe this is 0 point, this is your A point. Okay, and this is whatever it is. Now from velocity time graph, if I have to calculate the displacement s, I would find the area of this curve. I would find the area of this curve. This is a triangular curve, so area is half into base into height. Now for example, let's put some values out here. Let's put some, sorry, let's put some let's put some values out here. Let's say this is my 20-second point and this is my maybe 40 meter per second point. Okay, so what is the distance if I have to calculate how much is the displacement from 0 to 20-second? What is my displacement? That means body was starting at rest, how far that body has gone. That means if they are starting at point A, after 20-second, after 20-second, how far, after maybe this is my 20-second time, how far the body has, I have to find the displacement, to find the displacement. Okay, so I would do half into base is how much, base is this 20. Okay, and how much is height, 40. Okay, so I would find the body has traveled 400 meters. Within this 20-second, the body has traveled 400 meters. So from this area of the curve, area of the curve, or area of, or we can write this displacement, right, like displacement, let's write displacement. Displacement can be calculated from velocity time graph by finding the area. Okay, let us use a different color. By finding the area of the curve or graph. Okay, so displacement can be calculated by finding the area of the curve. Now in most of the cases we would be having this curve as some geometrical figure, like maybe this is one kind of a situation. Another situations that we can have, which is very common, in your case also. Like if I take another velocity time, sorry, if I take another velocity time graph like this, like our last example, it could be like this, like this, right? Like this, straight line. So maybe this is my 0 second. Maybe I will put this as my maybe a 10 second. Maybe this is my 20 second. Maybe this is my 25 second. These are all time axis, so these are all in seconds. And here I can say this point in my velocity axis is, okay, this is my 20 meter per second velocity, and this is my 0 meter, obviously starts with 0. Now if someone asks, okay, can you tell me if the body is moving like this, if the body is moving, so this is a curve of a movement of a body, like you have seen the video of this card is moving and we're getting a graph. So body is moving, so the body is moving. Can you tell me the displacement? Can anyone tell me from this what will be the displacement of the body, what would be the displacement of the body for the time period, oh okay, what is the displacement of the body at 10 seconds, or after 10 seconds, what is the displacement of the body? Or we have to find displacement of the body at 10 seconds. What will be the displacement? How do you find the displacement of the body at 10 seconds? We have to look into this curve. See, this is my 10-second mark, so I would be only finding the area of these curve, these one, the one that I've done with yellow. Let's say this is A point, let's say this is B point, let's say this is C point, let's say this is D point, and let's say this is E point, and this one is my 0 point. Okay, so I have to find the area. I will use a different color. I have to find the area of triangle AOB to find the displacement after 10 seconds. What I will be doing is half into base is how much? 10. Okay, and how much is the height? How much is this height? 20. So the body has traveled, the displacement of the body is 100 meter, 10 into 10. Okay, right? Now this was the first part. Now if someone asks what is the displacement of the body after 20 seconds, if the next question is displacement of the body at 20 seconds or after 20 seconds, okay, how do you find out? Area of this rectangle, okay, only plus area of the triangle. Very good, very good. After 20 seconds means at this point, that means I have to add this plus I have to add this. So this I have already calculated, so I will only find, so we know this displacement will be given by area of triangle AOB plus area of rectangle ABCD. So I have already know the area of the triangle AOB, so let's just find the area of so this is 100, already know from last calculation. So what is the formula for area of rectangle? Do anyone remember? Length into breadth. Length into breadth, right? So what is the length and what is the breadth out here? This is my one. If I take this is my breadth, so this is 20 minus 10, 10, and this is my breadth, this one. So here it's 20 L into B. So 100 plus 200. So this is 300 meter. Right? This is 300 meter. Clear? Easy, no? Very easy. Okay. Right. Now, if anyone asks you what is the total displacement of this body, what is the total displacement happened during this motion? Total displacement. How do you find out total displacement? Total displacement. Total displacement is nothing. That means I have to find the area of this total curve. This total curve. I have to find the area of this total curve. Total one. That means I have already done this and this and this. Let us also find the area of this rectangle. Okay, also find the area of this triangle. Also find the area of this triangle. Okay, so the total displacement is nothing but total this one plus this one plus this one, all total. I have already find this two. Let me find the third one so I can find it. Total displacement, I already know total displacement is nothing but area of triangle AOB plus area of ABCD plus area of triangle DCE. So this two I already know, which is 300 meter, plus I'll just find the area of DCE, which is half into base into height. How much is the base? Base is this much, which is 5, and height is again this much, which is 20. So this is 50. So my answer is 300 plus 50, which is 350 meter. So one thing you see, for the first 10 seconds, the distance travel is 100 meter. For the next 10 seconds, the distance travel is 200 meter. For the last 5 seconds, the distance travel is 50 meter. So the maximum distance they have traveled in the middle 10 seconds. Why in this time? Because here the velocity was maximum. Once the velocity is more, I will move more distance. When I'm at the speed ratio, if my speed is more, my distance I will travel is also more. So which is correct? Initially the velocity was increasing. It has not reached 20 meter. So I've reached a lesser point. Okay. And finally, the next 5 seconds, I have reached only 50. That means, hold on, that means my first 10 seconds and the next 5 seconds, my rate of change was same. See, 50 50 in 5 seconds is same as 100 in 10 seconds, right? So this slope and these slopes are same. This slope and this slope is same. It seems to be a steeper slope, but then I'm talking of only 5 seconds here. This is less steeper slope, but I'm talking of here 10 seconds. Okay, this is just some observation. There's nothing to do with your problem kind of a thing. And if I look into this, okay, now now can we find acceleration from here? For this OA, acceleration, if I'm trying to find this point O to A, we know rate of change of velocity. The velocity has changed 20 and the time is 10. So my acceleration is 2 meter per second square. Okay, here my acceleration is positive 2 meter per second square. That means velocity is increasing. Okay, here at this point, if I see what is my change of velocity, my velocity from 20 it becomes 0, so my change is 0 minus 20, which is minus 20. That's my change. And the time is how much? 5. The time is 5, right? So what's my answer? My answer here is my acceleration is minus 4 meter per second square. That means I've applied a brake. This minus sign means I'm having a retardation. That means I've applied brakes. This negative sign because I will always final velocity minus initial velocity. Here the final velocity is 0 at this point. The final velocity is 0 at point E, and the initial velocity was 20 at point D. But time can never be negative. 25 minus 20, which is 5, so 25 is 5. I have got this minus 4 meter. The significance of minus is it is retardation. That means it is something is reducing. So this kind of a questions will come in your exam in terms of the from the velocity time graph. From the velocity time graph, this kind of a question will come. Okay, right. Now we are coming to the last phase of our chapter where we have done some equations of motion. What have you done? Equations of motion. Equations of motion. Okay. See, we know some equation of motion. Actually, we know. স্যার আমি রিকানেক্ট করতে পারছি না ওকে সুমনা just hold on, okay, I will help you. Okay, we are back to this and we would be doing our last phase, that is equations of motion. Till last class, I mean till class 8, we know only one equation of motion. Can anyone tell me which equation of motion we know? We know, sir, distance is equal to speed into time. That's all we know. Speed equal to distance by time, distance equal to speed into time, time equal to distance by speed. That's all. Because during that time, we had only one speed. Okay, and the speed was not changing. The speed was constant. Okay, right. But now here we have, actually we would working on two type of speed. One is initial velocity or initial velocity, and another one is final velocity. Okay, that means we would denote initial velocity as u meter per second and final velocity as v meter per second, right? So now this equation changes. That's why you have got not one but multiple equation of motions, actually 3. And since this velocity is changing, we have come to a new term called acceleration. Which is called acceleration, which is called what is Rudro saying? Which is called Rudro, are you saying something? Acceleration, which is denoted by A and meter per second square. Okay, right. Because instead of one speed, you have got two type of speed that will be dealing out. The speed is changing because there is some acceleration. The equations of motion, will have 3 equations of motion. Great. Okay. Now let's make something very clear before this. We would denote displacement or distance covered, displacement, as S in the equation. Obviously the unit will be in meter. We'll be denoting time in the equation as T. Obviously the unit will be in seconds. We would be denoting initial velocity initial velocity as u, English alphabet u, u for umbrella, and we will be denoting final velocity as v, v for victory, and we will be denoting acceleration as a. Okay, this its unit is in meter, this is in seconds, this is in meter per second, this is in meter per second, this is in meter per seconds square. Okay, these are the few things we will be doing it. Let me also write these three equations here, and the next onward slide I will be deriving this equation, how it is coming from. Great. So the equations of motion are v is equal to u plus at. This is one equation. Second equation may be s is equal to ut, that is initial velocity into time, plus half a t square, right? And the third equation is v square is equal to u square plus 2as. Okay, these are the three equations: equation 1, equation 2, and equation 3. Velocity I will read out. The first one is velocity, final velocity is equal to initial velocity plus acceleration into time. This is one equation. Second is displacement s is equal to initial velocity into time plus half into acceleration into time square. And third is final velocity square is equal to initial velocity square plus 2 into acceleration into displacement. And these equations are of a body. These equations are of a body with uniform acceleration. Uniform acceleration. Okay, these equations of motions are equation of a body with uniform acceleration. If you have got a non-uniform acceleration, you'll not able to find it. Okay, this is things. Okay, so let's go a deep inside this. The first equation have what are the we have got four parameters. That is, we have got final velocity, we have got initial velocity, we have got acceleration, and we have got time. The second equation has displacement, initial velocity, acceleration, and time. We don't have final velocity in this. The third one has final velocity, initial velocity, acceleration, and displacement. It does not have a time in this. So based on in your question, whatever the availability of parameters given, whatever information is given, we will be using which type of equation. And this is of uniform acceleration. If there would have been a uniform retardation, if my speed have been decreased, we would have put in a negative sign in this instead of positive sign. That's the only difference, but you don't have to worry about that. We'll be only thinking of v is equal to u plus 18, s equal to ut plus half at square, and v square equal to 2 u square plus 2as. Now let us start deriving of this equation. Okay, can anyone tell me what's the definition of acceleration? Uh, okay, definition of acceleration is change in velocity per unit time. Change in velocity per unit time. That's a definition. From this definition, we know acceleration is denoted by a change in velocity is nothing but final velocity minus initial velocity, always final minus initial, by time. We can write final velocity as v, initial velocity as u, by time. Then you will do a cross multiplication, t goes there, so it become at is equal to v minus u. So now we'll take u that side. Just to get this equation, we'll write this as u plus at is equal to v. So my what happened to Rudro? Sir, can I join now? By mistake I missed class on time. How can you miss class on time? Okay, v is equal to u plus at. This is my first equation. So my first equations comes from the definition of acceleration. V is equal to u plus at. V is equal to u plus at is my first equation of motion, and it comes, if you remember definition, remember definition of acceleration, you would be able to find this thing out. You will be able to find this thing out. Okay, right. Now next, let's go to the next. So what we know this thing. We'll keep it handy. V is equal to u plus at. Okay. Now another thing we know, displacement. Displacement is equal to what? Average velocity into time. Okay. Displacement is equal to average velocity into time. We know this, right? Now average velocity, if you think there is this motion where, sorry, there is this motion of a body where my curve looks like this. So I'm having an initial velocity u, I'm having a final velocity v. This was my 0 second, this was my t time. So what's my average velocity? What would be my average velocity for this time period? The average velocity would be v plus u by 2. Like in a trapezium, we do know the this looks like a trapezium also. If I have to find the displacement of this, we know this is a trapezium, and these two are like the shorter side and the longer side. We can say this. So area of, if I have to find the displacement, if I have to find the displacement of this, the area of the trapezium would be given by half into sum of parallel sides, that is u plus v, into distance between them, which is t. So we can write, this is my average velocity. My average velocity is v plus u by 2 into time. Now from this equation we can say, we can write or we can say time is equal to v minus u by a. I have just changed this thing. Onubroto is disconnected. Okay, we can write this, t is equal to v minus u by a. So now I'm replacing this t with this, because I want an equation which does not have, which does not we see what we does not have a time. We'll start write an equation without t. So we can write this as v plus u by 2 into, instead of t is v minus u by a. So v plus u into v minus u by 2a. So what can I do with this? A plus b, a minus b is a square minus b square. So u plus v plus u by v minus u is 2a. I need some time. 10 minutes. Okay. So now we cross multiply. This. So we get 2as is equal to v square minus u square. Or if you just take it this way, we get v square is equal to u square plus 2as. V square is equal to u square plus 2as. Okay, this is our second or third equation of motion. One equations of motion. V square equal to u square plus 2as, which is v square is equal to u square plus 2as. Okay, how you did it? We have taken the average velocity. Average velocity means when the body was moving at velocity u and it has reached a velocity v within this time. So average velocity is plus initial plus final by 2 into t, and then from this equation that we know before, we have replaced t, and then we did uh, some algebra, a plus b into a minus b, and we got this equation, right? Now let's go to the last equation of motion. Again, we'll start with the same thing. We'll start with this. S is equal to average velocity into time. Okay, average velocity of done, we have see v plus u by 2 into time. So S is this. Now with the same first equation, we know v is equal to u plus at. What we will do, we would not replace t here, we'll replace v here. So instead of v we can write this, right? Instead of v we can write this. So what we will be writing is S is equal to, instead of v we'll write u plus at and keep the remaining things same. I'll write S with red. So remaining same, only changes, instead of v I have written u plus at. Where you got it? We got it from here, right? Great. Now we'll do some algebra. We all are very good at algebra. U plus u is 2u plus at by 2 into t. We'll open the bracket so you can write 2ut plus at square by 2 by 2. So we can divide this numerator as 2ut by 2 plus at square by 2, where this 2 and 2 got cut, and we would get something like S is equal to ut plus half a t square. S is equal to ut plus half a t square. That gives us the third equation of motion. And this is also for the same kind of a motion. If we have a motion this as t and this as v, like last we were having like this, the initial velocity was u and the final velocity was v, and we were talking of in time t period. So the same kind of a thing, what you have found, the area of this, again average velocity into time, this is okay. But instead of replacing t here, we are replacing v. So we have got these three equations. Now we will be using these three equations for all kind of our problems. We'll be using these three equations for all kind of our problems. Okay, this was your class today, and this was your class today, and this entire thing gives you this entire class gives you a total everything that's there in your motion in one dimension. Okay, this was a revision class because I wanted you to recall all the concepts that you have been doing for the last 1 week or so, and a few of the new students also joined, so for them also we're doing this. So after this we'll have only one more class. In that class we'll be discussing only the important numericals. Only the, maybe there'll be 10 to 12 numericals we'll be discussing. Okay, so the next class will be only on numericals class. And before that class starts, obviously next week, maybe I'll give you the dates. Maybe it will be normal date on Wednesday, or maybe we can have a class prior to that, maybe on Saturday, Sundays. I will let you know, guys. But that class will be on numericals of motion in one dimension. I will be discussing at least 20 different types of problems that we can have in our exams. I'll see for the last year or so what type of problems have come in your uh, question papers, and we'll discuss the important problems. But before that, kindly go through all the examples of the book. Kindly go through the numericals of the book. Try to solve yourself. So in that case, if you have any doubt, you can send me the doubts before. So on that next class, we will discuss all of it. Okay, I think that is